This is section 2.1, and we'll talk about frequency distributions. The first thing is the definition. It basically shows how data is partitioned among several categories or classes. So let's look at an example here. We have these different colored balls, and what we'll do is we'll write out the categories. I'm using Excel here. Red, blue, green, pink, yellow. And so we have all the categories that we see, and then the frequency would be basically how many there are of that type, right? So red would be 3 reds, blue, 2 blue, green, 2 green, pink, 3, yellow, 2. And so we can find the total then. If we use Excel to find the total, you can use a sum feature by writing equals sum and then a parenthesis. Highlight what you want the sum of and your parenthesis and hit enter. That's called a function in Excel. So this would be the total. We can count them. There's 4 there, 8 and 12. So this represents a frequency distribution of the different colored balls that are present. Now look at this frequency distribution over here. We have time in seconds, and it has different classes. So we have a time from 75 to 124, 125 to 174, and then we have frequencies of drive-through McDonald's service times. So 11 were between this time, 24 were between this time, 10 between this time. So again, this is just a frequency table showing the tallies of cars that came through the McDonald's service line. Now let's look at some definitions. We have a lower class limit, an upper class limit, the class boundaries, midpoints, and width. So these are lower class limits: 75, 125, 175, 225, and 275. They're the lower values of your width here of time. The upper class are obviously the 124, 174, etc. The class boundaries are something a little different. It's what's between 124 and 125. It's halfway between that, and you put it on the left side and right side. Let's look at an example so you can understand what I'm talking about. So here's a problem. Has the same kind of idea. Age, and then the frequencies, and it's asking for lower class limits. You just write it in. This is a problem in your homework, number 4. All the lower ones. Then the upper class limits, all the upper ones, the one on the right side of the limit. Then let's go down to the boundaries. So the boundaries are the numbers used to separate the classes, but without the gaps created. So you see there's a gap between 24 and 25 of 1. So take that width of 1, divide it by 2, and you get 1/2. You add that on to this upper class, and you subtract it onto the lower class. So the class boundaries for this first class would be 14.5 to 25.5. And there's the 14.5. The next one would be 24.5, 34.5. etc. So those are considered the class boundaries. There's those midpoints from each lower class to the upper class, or upper class to lower class, vice versa, and starting at the beginning and end, don't forget the 84.5 at the end. The class midpoints are going to be the values in the middle of the classes. So that means you take the 15 plus the 24 and divide by 2. You're actually finding the middle of that class. So 15 plus 24, hit enter, divide by 2, and the middle of that class is 19.5. So you will see the midpoint being 19.5. 25 plus 34 divided by 2, 29.5 is the actual class. Stay within the class. Don't go 15 to 25 and divide by 2, 15 to 24. The class width is the difference between the two consecutive lower classes. So you can see it by going like this: 15 to 25, 25 to 35, 35 to 45. So our class width is 10. If we come back over here, we see that the class width from 75 to 125 would be 50, right? And it continues up by 50, 50, and 50. So the class width is defined by lower class to lower class. Relative frequency distributions. So if we had a frequency, the relative frequency is basically the percentage frequency distribution. So you need to compute what percent is, for example, 28 in the 15 to 24 year olds. What is 36 in the 25 to 34 year olds? So you need the total to find what percentage 28 is. So we add them all up and then divide. So let's look at our example here. Relative frequency is the frequency of the class divided by the sum of all frequencies. And then you just multiply it by 100%. So here's my example of McDonald's drive-through lunch service times again. 75 to 124 was 11. 125 to 174, 24, etc. Let's add them all up. And you can see I've already done that. 11 plus 24 plus 10 plus 3 plus 2. That's why you have a calculator, you get your 50. That's the total. The relative frequency is what percent is the 11 out of 50. 11 out of 50 is 22%. Or you can see it's written as 0.22 or 22%. The relative frequency for 125 to 174, we have 24 of those. So 24 divided by 50 is 0.48 or 48%. And you just go down the line. So it's nice sometimes to have a Excel to help you. So you don't have to do it on the calculator. Of course you can use the calculator. But here's an example with Excel doing the same exact thing. I have a response of never, rarely, sometimes, most of the time, and then always. And then my frequencies are shown. They're bigger numbers. So all I'm going to do is find the sum of them. And remember I showed you the function here. For Excel would be sum would be equals sum. And then parenthesis and highlight and hit return. 2067. Now I'm going to make my relative frequency over here. So I'm going to label it. And all we're going to do is create a little function here. The relative frequency as shown over here was the frequency for the class divided by the sum of all frequencies. So equals, the frequency is this cell, I click it, divided by the sum, this cell, and hit enter. 14%, that's 296, just to confirm, divided by 2067. 14.32%. And then we can just write that or have Excel do it for you, right? So what's nice about Excel is that we can pull this function down. So let's look at the function here. It says, when I click it, it says the blue box divided by the red box. Now when I pull down, it's going to want to pull down the list, but it's also going to pull the red box down. To stop that, we need to put a $sign in here. Now watch, if I don't, the $sign just tells it don't pull down. If I pull down, I get an error. That's because the next box moved down to this one, but it also moved down to this one. So what I'm going to do is step back here, and I'm going to go into my function and put a $sign in the middle, just like that, and then I'm just going to hit enter. So I put a $sign up in here, hit enter. Now when I pull down, it keeps pointing at this 2067, and each one works. So these are all the percents. We can either type them out or format them as percents as a number. Format, percentage, 2 decimal places, enter. I don't have to do any thinking, and this should sum up. It's been rounded now, but it should sum up to 100%. Now we can do the same thing in statcrunch. If you prefer just to keep doing statcrunch, you can do that as well. So let's quickly look at that. StatCrunch is a little bit different, but it's the same data. What we're going to do is go into Data, Compute, Expression. You're making a function here. And you click the build. And what we're going to do is build that same kind of relative frequency. So the relative frequency was the frequency value divided by the total. So I'm going to click frequency, add, it comes up here. Then I'm going to put in the division symbol, the bar there. The sum, which is a function, because I got to add them all up, I go to sum, add function, and then click again frequency. Because you're going to sum up all the frequencies. So the frequency divided by the sum of the frequencies, exactly what it says. Then click OK, which is down here at the bottom. Comes back in here with the expression, and then I'll put a label in there called relative frequencies. As soon as I click compute, it's going to label that. See, I labeled these two. It's going to label that. And there are the frequencies. Again, now all you have to do is just get the 14.32%, 19.44%, or 45%. Remember to round, right? 44.41%, and put the answers into the MyMathLab. So that's how you can use this to help you compute relative frequencies. Otherwise, you can use the calculator. It just takes a little bit longer. Let's go back over here now. You can see that once it's all done, this would be called the relative frequency. It's in percents, right? And they all add up to 100. Now, the next one we're going to look at is called cumulative frequency. So here's the McDonald's one again with the same times, 11, 24, 10, 30, 3, and 2. But a cumulative frequency is where you add them up as you go down. So notice that it says less than 125 seconds. Less than 175 seconds. So the first one is less than 125 seconds or just 11, right? But the next one would be going to 175 seconds or less. So it's the 11 plus the 24. That gives you the 35. Then for the next one, less than 225, add the previous two over here, right? You're going to add now 11, 24, and 10. You've already added 11 and 24 to get 35, so just add 10. That's where you get the 45. The next one is 3, so add 3 to get the 48, and the last one's 2 to get the 50. That's the total. That's everything in the list. So cumulative frequencies mean add the frequency before it. Add all the frequencies before it until you're to the last one, which will include the total. It'll include all of them then. So that would be considered a cumulative frequency table. Okay? You can do that in Excel as well, but it's just this one seems a little easier. There's a lot of functions to be written out to do that. This one's pretty easy to just do it yourself by adding the previous ones to it. So pay attention. Are you dealing with a frequency table, a cumulative frequency table, or just a frequency table? What are you trying to create? What is it asking you? It'll say in the directions, and sometimes this cumulative frequency one is the one people miss on the exam. Last thing here, a question might ask, does this data appear to be normally distributed? Well, here's what a graph that looks normally distributed looks like. Notice this little blue curve here. I'm going to try to do a little thicker to show you what I'm saying. But this right here, this line is called a normal distribution. And the data, if it fits that, we consider it to be approximately normally distributed. Now you can see this data here doesn't exactly fit it. Well, there's nothing that's going to exactly fit it. What we're going to do is be close. What they're saying is, hey, on the far left here, as you get data in the 60s, are there just a few things? And then does that match on the other end of your spectrum in the 70s? And then as you come up in the 62, 64, is it the same on the other side as you're coming up? Is it symmetrical? So if you looked at the middle, does it look symmetrical looking right and left? And then the highest point is right in the middle there. That would be the highest value right in the middle, right? And you can see that this doesn't exactly happen for us, that highest value isn't in the middle, but it is right off the middle. That is okay. It's still pretty symmetrical as you go back and forth, right? So it says, look at this chart of the sun's height. The curve is considered a normal curve. The data is mostly fitting this normal distribution. Low on the left, high in the middle, and low on the right again. Now there's other types of distributions which we'll look at, but this is what they're saying is something normally distributed. It would match this kind of shape in data. So for 70, there are 120. Approximately 66, there are 82. And then is there about 82 over here? Not quite, but pretty close. There's 90, right? Okay, hopefully this has helped you. If you have any questions, please post them in discussion and follow into the My Math Lab homework.